Temperature and salinity in Langebaan Lagoon. I mentioned earlier we were very concerned when the Elandsfontein phosphate mine started dewatering their mining pit at the mining site at the head of Langebaan Lagoon. We were worried about what impact that would have on groundwater flow into Langebaan Lagoon. Langebaan Lagoon is a marine embayment. It's a lagoon. It's got minimal surface freshwater input. There are no rivers flowing in there, but there is significant groundwater input. So groundwater from the aquifer, the Langebaanweg aquifer, flows underground and pops up in the lagoon. And because the lagoon gets very warm in summer, there's a lot of evaporation, it tends to get quite salty. The salt levels get very concentrated in the lagoon. So we were concerned that if you interrupted groundwater flow into the lagoon, it would result in the lagoon becoming hypersaline. Hypersaline means more salty than the sea. Normal seawater has got about 35 grams of salt per liter of water. Hypersaline, we're talking 40, 50, 60 parts per thousand. Most marine organisms cannot tolerate high levels of salt. So if the levels of salt go, say, above 40 parts per thousand, the water becomes toxic, and most of the birds, most of the fish, most of the organisms in the lagoon would suddenly die. So we were very concerned about this, and we started monitoring salinity and temperature levels at the head of the lagoon to get an idea of, firstly, what are baseline levels like? What were the levels like before they started mining, before they started pumping that groundwater, so that we can compare them to now when they are actually pumping the groundwater. And how effective is the recharge system by when they're pumping that groundwater back into the aquifer? Is it working? Is it preventing this hypersaline condition from developing? And I can happily say that it has been very successful. We've got very interesting data here again, nice seasonal pattern where conditions are warmer in summer, January, February, than they are during winter, July, August. The red is the temperature, and there's lots of daily fluctuation during the day. When the sun shines, water warms up. At night, it cools down. So that's that high frequency signal you can see there. And the longer term signal is the tidal cycle, spring neap tide cycles. During spring tides, tidal flushing is much greater, so temperature varies much more in the lagoon than during the neap tides when the tidal flushing is smaller. Salinity, very similar pattern here, but the pattern is now driven exclusively by the tides. So this is salinity. Look there. Normal seawater, as I mentioned, is about 34 and a half, 35 parts per thousand. And but in summer, the lagoon tends to get quite saline, around 40 parts per thousand. So it's on the verge of where it would become toxic to many of the species that live there. During winter, it drops down much lower than seawater, less than 30, 28, 30. That's the normal, natural pattern. And thankfully, they've been pumping the groundwater from the Elandsfontein mine for the last 2 years, I think now. And we're not seeing any change in that. That pattern has persisted, and I'm very thankful for that. We do have a couple of interruptions in our data. Someone picked up our mooring and moved it off somewhere further down the lagoon, so there's an interruption there, and that's when we took it out of the water to service it. But otherwise, I'm very pleased to be able to say that that my concerns about the Elandsfontein mining operation were completely unfounded. And so far, we're not seeing any impacts on groundwater flow into Langebaan Lagoon. Next slide, please. Okay, so the other thing we look at when we consider water quality, very important, is fecal coliforms. Fecal coliforms they come from warm-blooded animals. That includes us, but it also includes birds and fish. Those bacteria that live in our guts, and they find their way towards find their way to sea from sewage works, from stormwater runoff, from all over the place. And we look at levels of fecal coliforms on the bathing beaches at a series of sites around the perimeter of the bay, to gauge their suitability for what we call contact recreation. So fecal coliforms in themselves, E. coli, enterococci, don't pose a significant risk to human health, but they're merely indicators of the possible presence of other pathogenic organisms that are associated with human feces, like cholera. So we use these indicators, and it tells us a whole lot about the suitability of the bathing, of the beaches, of the sites around the perimeter of the bay, their suitability for contact recreation. We've got Saldanha Bay Water Quality Trust has been doing this monitoring in conjunction with the Saldanha Bay municipality for the last almost 24 years now. There are 20 stations. There's a whole collection of stations around Small Bay there. There are a whole collection around Big Bay. And then there's a series of stations in Langebaan Lagoon. Unfortunately, I had an animation on this slide which would have brought this picture in and then taken it away. I don't know what's happened to the animation there. So unfortunately, the data from the early part of the record, you can see 1999 here. And these are each column of data represents 1 year of monitoring. And these results give an indication of the suitability of each of these sites for contact recreation. So it's categorized from excellent in blue, where we think it's completely safe. There's no indication of fecal pollution. Completely safe to go swimming there, to go kayaking, to go surfing. Through green, which is good. There are some fecal coliforms present in the water, but you probably don't need to worry too much about it. Fair, there are quite a lot of fecal coliforms in the water. There is a significant risk that there may be some pathogenic organisms in the water. You may get an ear infection. You may get ill from swimming there. Through to poor, which is red, which just says it's patently unsafe to go swimming there. During the early part of the record, which is unfortunately covered by this picture over here, a lot of the areas in Small Bay, a lot of the beach sites in Small Bay were in a poor state of health. In Big Bay, mostly in a good, excellent condition with a few fairs. And in Langebaan Lagoon, in the early days, we didn't do much monitoring here. But if you see around 2011, 2012, most of those sites are in really good condition. I want to focus specifically on the last 2 years, which is 2022 and 2023. I've highlighted in red and yellow there. Conditions in Small Bay haven't really changed much in the last 10 years. The number of stations, there are 2 stations which are ranked as poor. The one is opposite the Bok River mouth, where the outlet for the Saldanha Wastewater Treatment Works is. The other is in Pepper Bay, right in the corner of the bay there, where circulation is very poor, a lot of stormwater carrying fecal coliforms into that area. Other sites around Pepper Bay are also in rather poor condition, but it hasn't really changed a lot in the last 10 years. Conditions in Big Bay and Langebaan Lagoon have unfortunately changed quite dramatically in the last year. Compare all excellent with one at good to a situation in this year where there's a very large batch of fairs, some goods, and only 3 excellents. Situation has changed very dramatically on the beaches in this area. Those 4 beaches there is what I'm focusing on. Situation has changed very dramatically. And next slide, please. I suspect it's got something to do with this. Upgrades to the Oosterwal Road. The municipality has recently done serious upgrades to the road infrastructure. Those of you who live in Langebaan know about it. Your traffic has been disrupted quite extensively. A lot of the stormwater, there's been an increased funneling and channeling of stormwater down onto the beaches in this area. And we see that with the result of quite serious erosion with the increased storm flows of stormwater running onto the beach there. Quite serious erosion in some places along Langebaan Lagoon Beach. Quite a lot of litter going into the lagoon. But I think too, which we're not able to measure so easily, is the increased input of fecal coliforms. These are fecal coliforms that are washing off the streets, drains, people's gardens, washing down into the lagoon here, and it's impacting on the beaches in Langebaan Lagoon. For me, something to be quite concerned about. Next slide, please. Last thing on water quality, we use levels of certain trace metals, some people call them heavy metals, in mussels that we collect around at various sites around the shoreline. So very complicated picture here, but what you'll see is each one of them comprises of a little map with a series of 5 stations on it. This is Small Bay. We're focusing our attentions in Small Bay because that's where most of the industry is concentrated in Saldanha Bay, and that is where we find the most trace metals in this area. And we've got data here for 6 different trace metals. In each case, same 5 sites. And this is time series data going back to the 1980s towards the present day. And we collect a batch of mussels from these sites on the shoreline, and we take them to the lab. We test them for these trace metals. These are the ones that we are concerned about from a human health perspective. In low concentrations, they don't pose any risk, but in high concentrations, they do pose a risk to human health. And most of these graphs, you'll see a little dotted line running across the top. It might be in green there. Sometimes it's in red. It's in red over there. And if you just glance at all of these pictures here quickly, you can see that some of them, levels in the mussels greatly exceed what is normally accepted as safe levels for human consumption. So in the case of zinc, no problem except maybe one little problem there once upon a time in the corner of the bay. Cadmium, no real problem there, 1 or 2, sometimes close to the line, sometimes exceeding the line, but mostly not a problem. Lead, definitely a problem, frequently exceeding safe levels. In this period here, back in the 1990s, early 2000s, the safe level for lead is at about 1.5, 2 milligrams per, 1.5 to 2 parts per million. Here, these values are around 150, 100 parts per million. And it's here at the site close to the multi-purpose terminal where the lead export is happening. So we think very firmly that these problems were associated with the lead export here. Definitely has improved in recent years. It's not nearly as bad as it was. You can see there are still some concerns, but definitely has improved in recent years. Copper, not a huge problem in the bay. The safe level for copper is quite well off the top of that chart. But interestingly, the highest levels of copper are here in the corner of the bay here, where the ship repair or the small vessel repair operations are going on. We don't think it's linked to exports of copper ore. We think it's mostly linked to ship repair activities. Manganese is another interesting case in point. Manganese ore exports have increased quite dramatically over the last few years. Manganese exports commenced about 5 years ago, and we've seen quite a dramatic rise in levels of manganese in the sediments, particularly in the area in close proximity to the multi-purpose terminal, where the manganese is being exported. Not so bad in other parts of the bay, but basically that manganese dust is being carried by the wind in this direction and is affecting particularly those 2 sites. But I must stress, safe levels of manganese are somewhere up here, so it's nowhere is it posing a risk to human health. It's just simply we are observing increases. Iron ore exports went up dramatically in the early part of this record, and we see in some sites do see some evidence of that increase, but have stabilized. But Transnet have put quite a lot of effort in trying to control dust from the ore terminal, and that certainly seems to have paid some dividends in terms of levels of iron. Again, iron is not particularly toxic, and the safe level for iron is way off the top of that chart. So really, the only one that I'm concerned about is lead, and for many sites around the perimeter of the bay, the mussels along the shoreline are potentially not really suitable for human consumption. Next slide, please. We also have data on trace metals in cultured mussels and oysters. This is from the mariculture rafts offshore, and there the situation is much better than on the shoreline. These mussels are mostly in exposed to newly upwelled water that's coming into the bay from the deep sea, and levels of trace metal in that water are much lower than they are on the shoreline. So if you look at these graphs, the levels of trace metals for most of these species are lower or below the levels of concern. Arsenic there's a few occasional concern. When we get very intense upwelling, we sometimes get elevated levels of cadmium in the mussels from the rafts, but mostly these are much lower than those in the bay and relatively safe. Next slide, please. Likewise for the this should say oysters, I'm sorry about that, but oysters even lower. They tend to grow faster and they're harvested within a shorter period of time than the mussels are. So levels in oysters are in the bay are perfectly safe. And so those of you that eat, most of the mussels and oysters you eat in the restaurant come from the offshore rafts, and you can eat those with confidence. Next slide, please. This is some information on sediment quality in the bay. I'm just going to go through this very quickly. We have been monitoring sediment health in the bay for at least since the 90s. The Water Quality Trust has been monitoring levels of sediment, particle size, and trace metals in sediments in the bay back to around 1999. Right through to the present day, pretty much every year over that period, but intermittent in the early period. But this is data on the amount of very fine particles in the sediment. So when we look at sediments, we tend to, there's a range of particles from very, very fine particles, less than a tenth of a millimeter in size, up to very coarse particles, several millimeters in size. We are often concerned about the fine sedimentary particles because they tend to reduce oxygen flow through the sediment. They tend to have higher levels of trace metal. So we've been looking at levels of mud. That's the percentage of the very fine material in the sediments in the bay. And you can see there varies from around 40% right through to 0% of the sedimentary material. And that's from around 35 stations all the way around Saldanha Bay and Langebaan Lagoon. And what is very, very nice to see is how that has declined over time, quite dramatically. Back in the early 2000s, levels were very high, 20, 30, 40% of the sedimentary material in the bay was comprised of fine sediment, and that has gone down very nicely over the years, both in Small Bay. These are a series of sites in Small Bay. These sites in Big Bay show a very, very similar pattern. Langebaan Lagoon, less so. There was a period when there were very, very high levels of mud in Langebaan Lagoon in 2009, but otherwise they've been pretty low most of the time. So two reasons for that. I think one is linked to dredging activity. You can see the arrows at the top there. Those are dredging events that have taken place in the bay, and I've tried to scale the width of the arrow to represent the magnitude of the amount of sediment that was dredged at the time. Dredging tends to disturb sediments, mobilizes. The coarse sediments are taken, all the sediments are taken out by the dredger, but most of the fine sediments flow back into the water, and those fine sediments tend to settle out on the surface, and they tend to cause these cause levels of fine material in the bay to spike. And you can see how that in dredging intensity, these were when the port was still being constructed or expanded. We saw some major dredging events there that resulted in quite high levels of mud. Also, the increase in wave energy in this area may have contributed to this, because wave energy tends to suspend the fine particles and carry them out of the bay. So the increase in wave energy over time has probably contributed to this reduction in amount of fine sediment in the bay. And if you give me the next slide, that pays dividends in terms of the amount of organic material in the sediment. Organic carbon and nitrogen tends to be elevated in sediments with lots of fine particulate matter, and you can see in most of these sites, these data are from a slightly shorter period, organic carbon in blue, organic nitrogen in red, but in many sites you can see a corresponding decrease in the levels of organic material in the sediments as that fine material has been winnowed out. And if you give me the next slide, that tends to pay dividends in respect of trace metal levels in the sediment. Unfortunately, the slide is a complete mess. I had a series of animations where these different figures would come up at different times. So unfortunately, what you're looking at here, underlying the base of the slide here, is levels of manganese at 5 stations in the bay around the ore terminal. And this is over the last, I think it's about the last 10 years, shows levels of manganese over the time. We know that this is manganese ore export. We know that's increased quite dramatically over the years, started in about 2013, 2014, and now is at around 4,000 tons per year. Interestingly, for the most part, we don't see any evidence of increasing manganese in the sediment. We are seeing it in the mussels on the shoreline, but we're not seeing the manganese accumulating in the sediment. I can't tell you why. This is lead export data. Unfortunately, here underneath here is the lead levels, and you can see we don't have any data on lead export prior to 2010, 2011, but lead exports are have been going down slowly over the years, and but somehow levels of the lead in the sediment seem to be going up at most of the stations. This is zinc exports. We haven't been measuring zinc in sediments in the bay, so we don't know what's going on there, but certainly zinc exports have been going up quite dramatically over the years. Can I have the next slide, please? This is now moving on to biological organisms and what they can tell us about the health of the bay. Firstly, we look at benthic macrofauna. These are the little bugs that live in the sediment, little crabs, shrimps, worms that live in the sediments in the bay. And we've been monitoring these over the same time period and the same sites as we do for the sediments in the bay. And if you remember what happened with sediments over time, with that massive reduction in the level of fine sediment or mud in the bay going down like that, we can see corresponding change in benthic macrofauna populations in small bay. It's a bit messy, but there's very clearly an increase over time. Likewise with big bay, possibly a slightly clearer trend over time. These are numbers of different organisms in the sediments in the bay, and they've gone up very, very nicely over those years, and I think it's very clearly linked to this change in the amount of fine mud in the bay. Langebaan Lagoon, interestingly, has shown a similar trend. We don't see such a dramatic trend in the amounts of fine sediment in Langebaan Lagoon, but certainly numbers of organisms in the sediment have gone up over time. And to me, that's a very positive sign. That's an indication that the health of the bay has been improving over this period. We did a lot of damage in the construction of the Saldanha, the iron ore terminal, the causeway linking Marcus Island to the mainland back in the 1970s, 1980s. Lots of dredging, and that intensity of those operations has gone down dramatically and has given the bay an opportunity, or the organisms in the bay, to recover over that time. Next slide, please. Hard bottom benthos. This is organisms that live on hard surfaces, reefs in the bay. We don't know nearly as much about this as we do about soft bottom benthos. We do know, however, there's extensive areas of reef in Big Bay. It's mostly concentrated in Big Bay. This is side scan survey data that was collected in the 1970s. And we know that at that time, we knew that there was extensive reef area in Big Bay. We're pretty sure most of that still exists here. And we know that there are some very interesting communities that live on those reefs. We have been doing some work on studying these communities as part of the Aquaculture Development Zone monitoring work. And we're hoping to do a whole lot of more work on these going forwards. The only major concern around that is a lot of the activities that are happening in Big Bay. The Aquaculture Development Zone is kind of centered to a large extent on top of this reef. The oil and gas import operations are centered in this area on top of this reef. And historically, we always assumed it's fine. It's just soft bottom benthos, it's ubiquitous communities underneath those areas. But actually, no, it's not. There are a lot of these reef outcrops in those areas. They have high biodiversity on them, rock lobsters, fish. They are important for a lot of things, and we really need to get a better handle on, or better understanding of what organisms live there, how important are they, and yes, we're hoping to get that coming forward in the next couple of years. Next slide, please. Moving on to fish. We've been studying fish populations in the bay at around 16 sites around the perimeter of the bay. We survey those every year. Back to 1986, these are different colors, represent the surveys we've done over the years since 1986. And each of these areas, I've divided the results of the data. This is data on the number of fish species that we've picked up in the bay every year from those surveys. And I've split it between Small Bay, Big Bay, and Langebaan Lagoon. And if you look at those data fairly carefully, you can very easily see that there is a downward trend in most of those areas in the numbers of fish species living in the bay. So that's not such good news. It does suggest to me very clearly that fish abundance is declining over time, and that what we are doing to the bay is having an impact, and we're losing some of those more sensitive species, which is concerning. In terms of numbers of fish, these are same data. This is numbers of individuals, Small Bay, Big Bay, Langebaan Lagoon. We don't see a similar trend there. All of these are very noisy. There's no clear long-term trend over time, except if we look carefully at some of the species. This is in Small Bay. We know most of the industry is concentrated in Small Bay, and we do get the impression of some significant reductions in some of the species. This is blacktail, gobies, white stumpnose in particular. We were catching very, very high numbers back in the 1980s, 1990s, and now numbers have declined quite dramatically, especially in Small Bay. And that's because of the loss of shoreline habitat taken up by concrete, dolosa, also effluent going into the bay, increases in trace metals, organic pollution in that part of the bay. So fish, not such a pretty picture. Next slide, please. We heard from, it was Mike and Beverly this morning about birds on seabirds breeding on the islands in Langebaan, in Saldanha Bay. There are 7 islands in the bay, and there are important bird populations on pretty much all of these islands. Unfortunately, the bird populations have declined very dramatically over the years. These data start in the, unfortunately you can't read that, but these data start in about the early 1990s, and they go through towards the present day. We know that prior to that, mining of guano on the islands stopped prior to this. That mining of guano on the islands had a massive impact on these birds, almost wiped out many of these bird species, but the populations were able to recover after mining of guano was banned, and many of them, for example, the African penguin here, numbers peaked in around 2000 and then started to decline again. And that decline in the numbers was nothing to do with guano, but unfortunately to do with their food supply. This is data on pelagic fish catches or pelagic fish biomass, sardine and anchovy. That's the main food source for most of the birds that breed on the islands in the bay. We decimated these stocks back in the 1960s, 1970s. This graph starts at about 1990. Populations were just recovering there. They came up nicely in the early 2000s, reasonable populations of sardine and anchovy. And then we started fishing them hard again, and unfortunately they crashed, and with it crashed the birds that feed on those populations. The birds had a double whammy when the pelicans started arriving in the last, about 5 years ago. Pelicans, seals started predating on those birds, and you can see most of those graphs have a very, very low point at about 2 or 3 years ago. But what is really nice to see is since that time, numbers of breeding pairs on the islands for most of these species have rebounded in the last few years. And I think that's thanks to the work that Mike and Beverly are doing there in chasing seals off the islands that were otherwise disturbing these birds, and chasing away the pelicans that were otherwise predating on these chicks. So Big picture, very sad, long-term decline in the numbers of these birds, but quite encouraging is this rebound in the last few years for many of those species. That is penguins, there's white-breasted cormorants there's crowned cormorants and bank cormorants. Population very, very low of this one, but has rebounded a little bit in the last few years, which is very nice. Can I go to the next slide? The situation with shorebirds in Langebaan Lagoon. Is unfortunately very similar. We've got data from the 1975 towards the present day. This is in summer, and we have got counts from winter. Summer are the migratory birds. These are birds that breed in the Arctic tundra in the far north, Russia, northern Europe. They go there during our winter, the northern summer. They breed during the northern summer, and then they will fly back here, and they feed every year in Langebaan Lagoon. So they come here, they feed, put on weight enough so that they're ready to fly all the way up to the northern hemisphere to breed. Unfortunately, the numbers of these birds have declined enormously over the years we've been monitoring them, from around 50, 60,000 birds back in the 1970s, now down to about 5,000 birds. That's tenfold reduction in the number of birds here, and it's mostly the summer numbers. These red ones are the migrant birds. They're the ones that are flying back and forth to breed in the northern hemisphere. The resident birds haven't declined nearly as much, and you can see that very clearly played out in the winter data. Yes, numbers of these birds have declined quite a bit, but nowhere nearly as dramatically as those. And we think that the decline in the summer migrants is mostly because of disturbance on their breeding grounds, and also during the time that they are flying from the northern hemisphere to the southern hemisphere. In southern Europe, people like to shoot birds, and they shoot a lot of these waders as they come over here. But we also think that populations, condition of our estuaries, the feeding areas in the southern hemisphere in this country have also declined to quite a large extent. You can see that in the resident waders. These are the ones that live and breed here. They don't fly away. So we are 100% accountable for the decline in the numbers of these birds. We can blame this partly on somebody else. And there's numbers of some of the key species, curlew sandpipers. We used to see 20, 30,000 curlew sandpipers in Langebaan Lagoon every year. Now we're lucky if we see 5,000. COVID was really great. It enabled these birds to rebound. That little uptick there was during the COVID years. That was a direct response to COVID, when people were locked in their houses. They couldn't shoot birds. They couldn't disturb them on their breeding grounds. They couldn't disturb them on their feeding grounds. And the bird breeding success went up dramatically, and we saw a dramatic recovery in the numbers of these birds. I'm sorry to say that those numbers have dropped down again since COVID, which is a bit unfortunate.